LPP is a real-time system for some data. So we have to see the keywords called as manufactures, produces and creates. If you get this type of keywords in your question, so it is the maximization problem. If it is minimization problem, you can use greater than or equal to with availability of the product. Hello everyone, welcome back to my new session. I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, MYSURU. In my last session, I have discussed about the basic information about LPP. LPP stands for Linear Programming Problem. LPP is a real-time system for some data. Let us understand the formulation of LPP with mathematical model. So today I will discuss about the problems on LPP, Linear Programming Problem. So first problem, so this is your question. So your question is very big, but the answer is very small. It's very easiest concept. Understand the concept properly, easily you can score in LPP. So this is your first question. A company manufactures two types of products, X and Y. So this is your real-time situations for some data. So in LPP, we create a mathematical model for given data. So here, you just observe the question properly. A company manufactures two types of products. If company is manufacturing two types of products and all, so obviously company is expecting the profit, right? In LPP, we have to maximize the profit and minimization of cost. So a company manufactures two types of products. Product is X and Y. So I will write the table first. Products X and Y. Both the products passes through two machines, that is M1 and M2. So machines M1 and M2. Manufacturing of 1 unit of product Y requires 4 hours of M1. Listen carefully. Manufacturing of 1 unit of product Y requires 4 hours of M1 and manufacturing of 1 unit of product X requires 3 hours of machine M1. X requires 3 hours of machine M1 and 6 hours of machine 2. 6 hours of machine 2 and manufacturing of 1 unit of product Y requires 4 hours of machine M1 and 2 hours of machine M2. 2 hours of machine M2. First you have to see the products. So company is manufacturing two types of products called product X and product Y. And we have two machines, machine M1 and machine M2. So first write the given values of the products. And after this product values, so first we have to see the availability, time requires, etc. So total machine hours available per month. So total availability per month M1 is equal to 240. So this is the total availability for machine M1 is 240 and M2 is equal to 180. So total availability for machine M2 is equal to 180. So first write all the given values. Then if you have a problems, we have to see manufactures, produces and creates. So first we have to see the keywords called as manufactures, produces and creates. If you get this type of keywords in your question, so it is the maximization problem. So it is a maximization problem. So problem is on maximization. So first you have to see the keywords. If it is manufactures products and produces, so directly you can write the maximization problem. So here I have written the products X and Y and machine M1 and machine M2 and total availability have written here. After that, they have given if the profit of 1 unit of product X, if the profit of 1 unit of product X is rupees 40 and 1 unit of product Y is rupees 60. So they have given the profit values for X is rupees 40 and for Y it is rupees 60. How many units of product X and Y are to be manufactured in order to maximize profit? So companies manufactures two types of products called X and Y. They have given the product details and availability for the products. So here we have to maximize the profit. So if you get any manufactures, produces and creates, so obviously it is maximization problems. Otherwise it is minimization problems. So first try to write this given values, then you can write the LPP model. So what is the first model? So here I can consider this X product and Y product as X1, X2, X1, X2. Or else you can directly write it is X, Y, X, Y. Or else you can use X1 plus X2 plus X3, X1 plus X2, etc. and X1 plus X2, etc. or X plus Y, etc. X plus Y, etc. So you can consider any decision variables for representing the products details. So first I will write the products details. So here the company manufactures two products, that is X and Y. So first I will write the objective function. Objective function. So what is the objective function? So this problem is on maximization method. So first I will write the objective function, that is Z max is equal to, so what is the profit of this products? So 40 rupees and 60 rupees. 40 rupees for product X and 60 rupees for product Y. So I will consider 40X plus 60Y. 40X plus 60Y. So this is your objective function. So Z max, or you can take maximization, Z max is equal to 40X plus 60Y, or else you can take P max, profit max is equal to 40X plus 60Y. This is my objective function. This is very important in LPP model. So after this objective function, so we have to write, so first step is, first write the decision variables X1 or X2, X or Y. First write the decision variables and objective function. So it can be Z max or minimization. Next write the second step is objective function. So objective function in the sense you have to maximize the profit. It can be maximization or minimization. So objective function have written, so profit is equal to 40X plus 60Y. Then after this we have to write the constraints of these products. So very important. So we have to write the constraints. Constraints. So here for machine M1 and machine M2, we have some given values for product X and product Y. So here the decision variable have considered as X and Y. So I will take 3X plus 4Y and 6X plus 2Y. I have two decision variables for M1 and M2. I will take 3X plus 4Y and the second one 6X plus 2Y. So this is my constraints. So after that, after writing these constraints, you have to see the availability of the product. So availability, total availability per unit is equal to 240 and 180. So if you get any maximization problem, so all the constraints value should be less than or equal to. All the constraints value less than or equal to. If you get any minimization problem, so constraint value is restricted to greater than or equal to. Keep in mind, for maximization less than or equal to, for minimization greater than or equal to. So here this problem is on maximization. So I'll write less than or equal to, availability is 240 and second mission availability is 180. So this is my given constraints for product X and product Y. So first we have to take the decision variables and objective function and constraints. So last step is non-negativity restriction or non-negativity constraints. Non-negativity constraints. So non-negativity constraint is, so here I have two decision variables called X and Y. So X is greater than or equal to 0 and Y is greater than or equal to 0. So it should be non-negativity constraints. So after this, so finally we got the decision variables, objective function, constraints and non-negativity constraints. So finally you have to write the LP model. That means LP model is Z max is equal to 40x plus 60y and subject to constraints. So we got the constraints value, that means subject to constraints is 3x plus 4y less than or equal to 240 and 6x plus 2y less than or equal to 180. So these are called as subject to constraints. So first one we have Z max, that is objective function. Next is subject to constraints and next is non-negativity constraints. So we have two decision variables where x is greater than x and y is greater than or equal to 0. This is non-negativity restriction. So this is your LPP model. So very simple concept. First understand the question properly. So if it is maximization problem, so you can use this less than or equal to. If it is minimization problem, you can use greater than or equal to with availability of the product. So first try to write the table like this. So if you get any products details, so easily you can write the products. So you will get this product details. So you can use this method. If you are very good at writing this table, you can use this method and easily you can construct the LP model. First is decision variable, objective function and constraints and non-negativity constraint. So finally, you have to mention the LP model like this. So this is your linear programming problem. So linear programming problem is a real-time situation for some data. So this is your second question. It's very important question. It's repeated question. So here already we have the table for a given data. We have the table. So to seeing this table easily we can construct the LP model. So question is, a manufacturer produces 3 models, that is 1, 2 and 3. Manufacturers produce 3 models, that is requirements is 1, 2, 3 of a certain product using raw materials A and B. We have raw materials called A and B. We have 2 raw materials A and B. The following table given the data, formulate this problem as LPP. So using this table easily we can construct LPP model. So what is the first step? So first I will write the decision variables. So I will consider the first models as X and the first model as X and the second model as Y and the third model as Z. So this is my decision variables. Then after that I will write the objective function. Objective function. So this problem is maximization problem because they have given the keyword called as produces. A company manufacturer produces 3 models. So it is maximization problem. So Z max or max P. Z max is equal to, so what is the profit? Profit per unit is equal to 30, 20, 50. So I have So here I am using the decision variable called xyz. So I will take 30x plus 20y plus 50z. So this is my objective function. And the next step is constraints. So here I have two raw materials called A and B. Here for raw materials I have requirement per unit. So 235,427. So I will write 2x plus 3y plus 5z first constraint, and the second constraint for product B is 4x plus 2y plus 7z. So this is my constraints, and just see the availability for these two products, that is 4,000. It is maximization problem. So I will use the less than or equal to 4,000 and less than or equal to 6,000. So this is my constraints. And also they have given the minimum demand. Minimum demand for two raw material is 200, 200 and 150 for all the three models. 200, 200 and 150. So minimum divide. So minimum demand in the sense I will use x is greater than or equal to 200 and y is greater than or equal to 200 and z is greater than or equal to 150. So these three are called as constraints only. So here we got the constraint value. So finally we have three decision variables. So what is non-negativity constraints? X is greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0. So now I will construct the LP model. So what is the objective function? Z max is equal to 30x plus 20y plus 50z, and subject to constraints 2x plus 3y plus 5z is less than or equal to 4,000 and 4x plus 2y plus 7z less than or equal to 6,000 and x greater than or equal to 200 and y greater than or equal to 200 and z greater than or equal to 150. So this is my constraints and non-negativity constraints where x, y, z greater than or equal to 0. It is non-negativity constraints. So this is my LPP model. And the next problem is a TV company has to decide on the number of 27-inch and 20-inch TV sets to be produced at one of its factories. So here a TV company produces two number of TV, that is 27 inches and 20-inch TV. So first write the given instruction. TV company produces 27-inch and 20-inch TV. So first write all the given values, and market research indicates that at most 40 27 TV sets and at most 10 20 TV sets. So we have 27-inch TV and 20-inch TV. So market research indicates 40 for 27 TV sets and at most 10 for 20 TV sets can be sold per month. That is sold per month. So like this you can prepare the table and after that prepare a LP model. This is assignment question. So next question is two types of ads. Each ad of the first type requires twice as much labor time as the second type. So company is manufacturing two types of ads, that is type A and type B, or you can take hat A or hat B also. Each hat of the first type requires first type requires twice as much as labor time as the second type. Each type of the first type requires twice as much of the second type. So here for type A, I have written 2 because each type of the first type requires twice as much as labor time. And the market limits daily sales of the first and second type to 150. That is, market limits sales of the first and second type to 150 and 250. Assuming that the profit per hat, so they have given the profit per hat is 8 rupees and 5 rupees. So profit per hat is 8 rupees and 5 rupees. Formulate the problem as a linear programming model in order to determine the number of ads to be produced of each type so as to maximize the profit. So it is maximization problem. So here they have given the profit and market limits also. So here companies produced two types of ads have considered as type A and type B. So first I will take the decision variables as X and Y. And after that, objective function. What is the objective function? This problem is maximization problem. Max Z is equal to, what is the profit? 8x plus 5y. 8x plus 5y. Profit per hat is 8x plus 5. 8 rupees and 5 rupees. So, max Z is equal to 8x plus 5y is my objective function. And after that, constraints. So, constraints are 2x plus y. 2x plus y. 2x plus y. So, this is a constraint, and see this, it is the availability of the type. A company can produce a total of 500 hats a day. So, per day company can produce 500 hats per day. So, this is a availability of the product. So, it is less than or equal to 500. So, company can produce a total of 500 hats a day. That is the availability of the product. And so, this is my constraint. And also we have market limits. Here they have given the market limits. So, I will consider this X and this is Y. So, X is less than or equal to 500 and Y less than or equal to 250. So, this is my constraints value. And finally, non-negativity constraint is X greater than or equal to 0 and Y greater than or equal to 0. So, finally, you have to construct LP model. LP model is max Z or Z max is equal to 8x plus 5y and subject to constraints 2x plus y less than or equal to 500 and x less than or equal to 500 and y less than or equal to 250, where x comma y greater than or equal to 0. It is non-negativity restriction. So, this is your LP model. So, this is called as formulation of LPP. Using this real-time situation, we can prepare a LPP using mathematical model. So, this LPP helps you to reduce the complexity of real-time situation. So, this is an example for LPP model. In my next session, I will discuss more problems on LPP. Thank you.